Thank you so much for being here. My co-chair Kyle Elrod and I have been working very closely with this incredible team of researchers to bring over to this forum of the open house a little bit on the perspectives on what have we been doing as the grand challenges teams and as the Bridge Center, how we come together to figuring out the best practices for generating AI ready data and AI ready tooling. And so today you're going to hear each of our speakers will have 5 minutes to introduce their work. We wanted to make this all about the discussion. So it's just 5 minutes for an introduction to let us hear more about their work. And after that, we'll hear just all of your questions so that we can address them. Sounds good? We can get started? Okay. You've seen this before today, haven't you? And you've seen it over the course of the past 3 days. It's critical to us. It's an understanding, right? Like it's an understanding. We have to make sure that there is a defined set of characteristics that a data set can have in all of its associated metadata so that we can allow reliable ethical analysis by AI methods of all of these data sets that we're generating, right? And this all necessitates to be defined within use cases and operational limits, which means we also have to have sufficient metadata that supports reliable, appropriate post-model explainability analysis. So we truly are sitting down into the process of generating data that can be rolled out and off your hands with governance, of course, but just allowing everybody else and empowering them to make discoveries with the data that we're generating. There was a conversation earlier in the week, the Contact PI for the salutogenesis project, Aaron was sharing that people have asked this team, what are you doing this for? You're just generating data for others to actually make the discoveries. And yes, we are that crazy, right? This is exactly what the entire goal of Bridge2AI is, to empower you and everyone else to make discoveries with the hard labor of our sweat and tears. So the other things that the other things in this wheel is that in addition to this set of, or to describe the set of characteristics, we want to make sure that we enable the reliability of the data sets, because AI requires clearly defined and robust, transparent data acquisition. We want to make sure that we have quality of the data sets as well, because artificial intelligence demands comprehensive and unbiased collection. And we also want to make sure that, as you have heard this morning, that there are ethical constraints because the biomedical AI data sets have concerns with the scientific integrity of the pre-model data acquisition. And we want to make sure that our data sets have explainability, meaning that we must demonstrate the ability to show how the data and the results were obtained with verifiable transparency. With all of those concepts in mind, our teams have worked towards achieving the readiness of the AI readiness of their data.
Well, of course, the other half of computation is not just the data, but the tooling alongside of it. This has actually been less discussed in this consortium so far. I think mainly because a lot of the groups are coming from such different backgrounds and have such different use cases and needs that the tooling really is very independent per DGP. But there are overall themes, and I think we need to start talking about how to kind of collect these together into an overviewing theme of the different types of tools that are going to be necessary to kind of not only enable the generation of AI data, but also the utilization of it. So in terms of this chart that we would like to start to fill out again, and kind of we've started to survey some of the DGPs, and we want to talk to different people in the consortium, what are the different, how to fill this out. And so on the vertical axis, this is just the standard software development life cycle, going from alpha, where it's just development, it's going to change, it's not trustworthy, it's test code, experimental, moving to something that's actually feature complete, a little bit buggy, but usable, and then something that we would actually consider releasable to the public because it's documented and it's steady. And then finally, one thing we do need to consider also is packaging. In the bad old days, this used to be called, release into golden master, when they actually printed it to a CD and sent it out to the distributors. Now we don't have to do that. We have the internet. But we do need to take care in terms of how software is packaged. You can't just point people to GitHub and say good luck. There's dependencies, there's installation, there's all sorts of issues, and just pointing people at a README and saying go for it is not the best strategy. I think we need to look at, like, how is software packaged and distributed? PyPy, Bioconda, Bioconductor. These are different ways to get software out to the people that need to want to use them. And also, I would also encourage people to think about modularization. There are workflow engines out there like Nextflow or Cromwell. These things are built to chain tools together. They require wrappers around your tool to make them available so they can be put into these larger things, workflows. So with that in mind, what are the different types of software we think that the different DGPs and also the users of that data are going to be kind of using? And this is actually one area where we've thought about it and kind of laid out about 4 key areas. If you think there's more that should be illustrated here, more examples, we'd love to hear from you if there should be a 5th column here. But in terms of, what we think the different tools that we'll be seeing, first is data preparation. And this incorporates everything from bulk data processing. So like in the old genomics thing, this would be taking BAM files and turning them into variant calls, or normalization, color correction, image segmentation protocols. These are the things that take big files and turn them into more computable AI-ready data elements. Then, of course, there's going to be a whole branch of tools around standards. We talked about data standards. How are they enforced and encouraged, vetted, tested? If there is a schema, how do we verify the data is in that schema? Does it conform to that schema? If there's rules around fairness, how are those deployed? We've actually seen a number of the DGPs produce libraries around generating fair items. Another branch of software is all around de-identification, ensuring that the privacy is respected. There's tooling there that can be shared, distributed, and utilized, and also generation of the provenance and chain. We need tooling for that. There are standards for describing the provenance, but that's not something you want to do by hand. It's nice if there's tools around it. And finally, or additionally, there's also distribution. There's code for websites. A number of groups have to build websites to distribute their data. There's a whole library of search tools and client libraries. So a person can come in, just type the name of a data set and have it on their machine available. There's APIs in that as well. Data discovery, how is that communicated? This whole, we both in the world of GA4GH, there's whole discussions on how you do data discovery APIs. And so that idea of having those standards for connecting people to the data and the client library so they can localize it and start working on it is very important to make sure that it gets out there. And finally is the last thing, which is more of this kind of client-facing thing, which I would call scaffolding. Just because they have the data doesn't mean they can instantaneously start doing AI work. There's a lot of libraries in terms of how to load the files into memory, create matrices, build models. There may be like encoders, embedding, tokenizers, pieces of software that really help someone get to the point where they're actually doing machine learning and AI work rather than just figuring out how to open up the files and start constructing their first model. And a lot of that, can be in the form of just example code and hello worlds that people can copy and paste and get started and actually do that. And I think that's an incredibly valuable, branch of software and tools that will really kind of empower the community. So again, these are how we're thinking about tools right now and how we want to organize the overall view of tooling in Bridge2AI. But I think this is going to require a lot more kind of conversation because, again, this is a very broad spectrum of tools that we want to make sure that we can catalog. Thank you.
Please allow my under-caffeinated brain to rectify some errors. And so what I'll do is introduce you to this panel and what we'll do here. So Satrajit Ghosh is here from the Precision Public Health. Then we also have Sadnan Almanir from the University of Virginia on the functional genomics. We have Rishi Kamaliswaran from Emory University on the clinical care. La Colombiana doesn't know how to pronounce that last name. I'm sorry. I didn't ask you. And then Michelle Ribar. She is here from Oregon Health and Science University to talk about salutogenesis. Over the next few minutes, they'll share a very quick overview of how they've prepared their data for AI readiness and how they've prepared their tools for AI readiness. Kyle and I will join them up here on the panel, and then we'll take questions from you. We have some questions we want to share as well. So hopefully you'll enjoy the next few minutes. So let's go.
Wonderful. Okay, I'm going to keep this brief so that we can have questions around this. You saw the elements of this chart several times today. This is the AI readiness diagram, and the outer red is where we might want to achieve, get 100% on each of these dimensions. The blue represents where we are today. And I'm going to say one of the things that I hope to do is actually push us closer to the center, because the richer we get each of these dimensions, the better we will be. Now, Moni and Tim may not like me saying that, but I think that's how we evolve these dimensions to be even better than what they are right now. But you can't talk about the voice project without kind of thinking about the set of information that goes into this. So we have non-voice, voice, and speech tasks. This goes from breathing recordings, cough, glides like going and speech of various different kinds. We have validated questionnaires that come along with this that people have filled up to provide greater characterization of their disorders in various ways. So we needed this to be not just AI ready, it's AI plus human ready data sets, things that clinicians can understand, engineers can understand, and machines can understand. And we're looking at disease cohort. What were the inclusion exclusion criteria, recording environment, data sensitivity as identified by ethics, and that Hortense covered quite nicely earlier today, and rationale for protocols. This is all kind of that pre-modeling thing that Tim Clark talked about. How do we describe what went into the data generation in addition to what's in the data? And then we've kind of worked on standardized representations. This involved tools like RedCap, ReproSchema, FIRE, structured data set layout. We're using the brain imaging data structure, which is a different standard that was developed by the neuroimaging community and the Brain Initiative to help support neuroimaging data and other phenotypic information as something that reduces cognitive load, as something we can relate to over here in creating a structured data set layout. And then there's machine readable metadata. We are using JSON, JSON-LD to cover this. So, and everything is in machine readable data formats. We are hoping that if we throw an AI agent at this, it will actually do good work. I don't know that yet. Come talk to me in a few months. But that's our goal with getting data to be AI ready. But an AI agent is not going to necessarily understand the nuances of all of the data just by reading the metadata in the data set. So we've been building tools. B2AI Prep does generate this structured layout. It extracts voice, speech task relevant analysis features. It creates some of these data structures that are readily absorbable into existing toolkits for doing ML work. And it's an open setup. So it's all of this is on GitHub. Everybody can come and contribute to it. It's powered by SenseLab, which is kind of our underlying core package that processes audio data. You can do all kinds of things with it: classification, feature extraction. And even though Hortense said earlier that I might be the only person who can re-identify things from spectrograms, I can tell you and assure you we have toolkits that you can do so too. We can do all kinds of things, including things like understanding how well can we clone voices if we are going to think about how well can we de-identify voices. And all of this is built on top of existing standards and work. So we're using LinkML, we're using BIDS, we're using ReproSchema, and we're standing on the shoulder of a lot of open source tools and software. Python, PyTorch, OpenSmile, Pratt, Torch Audio, Pydra, workflow systems of different kinds. And this allows us to build a resource that's richer than the sum of than the individual parts. It's creating and bringing a whole set of tools together that you can use for your analysis. And hopefully, these future agents, which will interact with this, can also use and depend on They are not making up things. We have a lot of knowledge in how we process voice. With that, I think I'm going to pass it on to the next person.
Hi, I'm Michelle Rybar from Oregon Health and Science University, and I have to make disclosure at the beginning. I am relatively new to the project, only about 7 or 8 months in. I was involved at the very beginning and then got this tremendous opportunity to spend 2 years at the NIH as a data scholar. So I just came back. So a lot of the work that I'll present here was actually done by Bhavesh Patel and is really kind of attributed to him. So in the Genesis, DGP, we are collecting a multimodal data set about diabetic patients and normal healthy patients as well. We are collecting just so many different types of data that not one standard fits them all. So for the tabular clinical data that can be represented in OMOP, we have mapped it to OMOP, and that's the way we're storing it. But things like ocular imaging, the ECG, at-home monitors need their own standards, which we have selected. We also mapped and answered the assessment for our AI readiness and found that we met a lot of the criteria. And this was thanks to a lot of the work that our team has been doing in sharing the data in fairhub.io, formatting the metadata in not just one, but 2 different formats, having the structure of our data set standardized, providing health sheet and data documentation. And as you've heard through our Swiss cheese model, one of the elements of that was developing a novel health data usage license. And the one area that we are still working on is we will be adding checksums in the future for verifiability. So for our tools, Bhavesh, when I say we, I really mean Bhavesh and his team, and the team at OHSU has been working a lot on various tools for various stages or functionalities. So we've developed our data portal where we actually provide access to the data, but we also have provided dashboards that characterize the data that we've collected so far. You've seen some of those figures or those graphs already. We've developed a pipeline. We have tools available for that, API, as well as Python libraries for generating the metadata. And as I mentioned, this is all great work that has been done by our entire team, led by Bhavesh, myself, Sharon and Shannon at OHSU, and Aiden is also here and a representative of that team. So thank you very much.
Good morning. I'm Xiaohun from Emirates, stepping in for Rishi. So AI was called pattern recognition maybe 20 years ago, what's called data mining 10 years ago. So for people like us with that background entering the healthcare, typically we start with ICU data. Why? Because ICU data has such richness in terms of the modality, in terms of the temporal variety of data. Now, in that 20 years of period of time, Mimic was the only available open data set for ICU. So what the Chorus is doing now is to amplify that by a factor of 14. So that's basically the essence of what data Chorus is generating. Then later on, we developed this idea of ICU data is not just only for that 2 weeks, 1 week of time of your life. In our pediatric population, the ICU mortality rate is only 2 or 1%. Many of the kids survive and end up, having to deal with some conditions. Even in the adult world, right? After ICU, there are lots of conditions you can actually study and track. So think about ICU as a starting point to launch a llama-rich investigation. So that's another kind of usage of this data. Now, yesterday I presented about using the ICU data to build a foundation model and use it in ambulatory home care settings. I think that is coming because the common data modality we have is this continuous physiological data, ECG, plasma graph, right? We collect that every single heartbeat in the ICU patients. But nowadays, you can also have that data in llama settings. But the ICU is the place you also have very frequent investigation of the organ systems, liver, kidney, heart. So can you actually make a case that you can use continuous data to also estimate the function of those organ systems in ambulatory settings? So that's another uniqueness of the ICU data. I think Eric already did a very good job this morning going through some of those tools. And I want to kind of emphasize that in contrast to some of the existing data sets you can download from the ICU setting, we have decided to really fully embrace this trusted research environment idea. This is actually up and running, has been working for maybe hundreds of users now. So in that environment, we team up with Odyssey and we have deployed Iris Atlas to interrogate, unmapped tabular data in our data set. And also, right, in one way or another, we actually are liberating the data from the EHR. As we know, EHR is not a good system to visualize, interrogate the data. So early on, we decided to build, from ground up, an integrated viewer where you can actually look at your EHR records, images, waveform data in one place. And I think that's very important for modelers to actually understand what they're dealing with, what's the patterns a human can recognize before you're actually doing modeling. So very proud of doing that. I think Dale is actually here, the one who actually developing, designing this. In addition to viewer, early on we also recognize we need to actually build a very comprehensive annotation tool because when we do AI modeling, we know the value of the labels, right? Not only to train the model, but really to verify and validate the results. So very glad to say we have built this Kata tool, which can be used to annotate waveform, annotate images, and also annotate clinical notes. Eventually, we are thinking about utilization of our data. At some point, we need to do benchmarking. We need to look at how your model perform. So I agree with Sachabai. So probably it's not just enough to point people to the GitHub to download the source code and retrain the model. Instead, I think there's a place that we should have we call the model meets data, or data meets model, right? Where you can actually bring your own data to benchmark, some models, or you can bring your model to our data to benchmark your models in that fashion. So those are kind of tools we're continuing to build. Anyhow, so be happy to join the panel for further discussion. Thank you.
Hi, I'm Sadnan Al-Munir. I'm the technical lead for Fairscape AI Readiness Framework. With my colleague Max Levinson and Justin Istroy, we have been continuously developing the Fairscape framework for almost a couple of years now. Typically, what we have been so far, we have released, we have actually processed data coming from the CM4AI pipeline. And the types of data that we have encountered so far are part-of-seq data, the protein-protein interactions data, the protein localizations data, and the data that are the hierarchical data that are generated from those mentioned above. As well as we have also released the AI-ready metadata and the data sheets. Now, in order to store those data, we have decided that we have decided to store those metadata and plus data in two different types of repositories. One is the generalist repositories to actually keep the metadata plus some types of data, and the raw data, which are domain specific, they're deposited into domain-specific repositories such as Massive and SRA. So the Fairscape tool, using Fairscape tool, we have been able to process and upload the whole process with AI-ready metadata into those repositories. Now, in terms of the tooling, Fairscape has been released as although we have been continuously developing it, Fairscape has been released as we have different interfaces to Fairscape. So it's a client-server model where we have for, let's say, tech-savvy, some programmers who are proficient with command line. We have a command line tool. We also have a graphical user interface, which is complement to that command line tool. We also have a server where you can upload all of this data and then look at the look at the provenance of those. So the one part that we have realized is that when we generate metadata, usually it's machine readable, but as soon as it grows a little bit large, it's not going to be understandable by humans. So what we have done in recent months is that we have rendered all of those machine readable metadata into human readable or human understandable HTML format, inspired by the Gebru paper, where the data sheets for data sets, we have explored that and we have integrated and extended all of those features and integrated those features into Fairscape. So if you can look at the diagram, you can see that once the data set is processed and released, users are able to explore those data sets and how the chain of evidence is present in those data sets. So starting from the result and initially from the sample, you can see that from the raw sample to the experiment, which resulted in a raw data set, like the semi-processed data set, then using the software and computation, the final result can be explored. And all of those items can be verified by going into the resolvable link. So you can actually, this graph is an interactive graph that you can explore by going into each of these nodes and expand them and verify them by going into the URLs that they are present in the, either they're in the raw repository, in the raw database, in the repository, or in, let's say, a generalist repository like Dataverse. In addition, not only we are taking care of the data sets, we are making sure that the software, every piece of software that are used in this computation, in this whole process of getting to the output from the initial raw input, are preserved in specific repositories. So we encourage people to put their software in GitHub. If not, we also use Zenodo and other generalist repository. So finally, I would like to mention that we are planning to include and extend the Fairscape metadata model so that all the grand challenges, so that the metadata model can expand to all the grand challenges going forward. And we hope to see great collaboration with all of you. Thank you.
Palm inward like this. See, nobody's doing it. Come on. And then bring your laptop screen down. There you go. And share with us some of the insightful thoughts that you've been capturing during this 30 minutes. So our hopes is that we've given you a little bit of a landscape of how we have been working on getting everything ready to be analyzed, utilized downstream, utilizing artificial intelligence and machine learning tools. So thank you. We'll take your questions now, Jake.
Yeah, thank you. I think thank you, Mani, for leading this. I still remember when we were preparing the AI ready paper, and then we had lots of discussions. So this is more of a thinking process, thinking aloud, and I want to just talk about some of the unresolved issue when we were preparing the manuscript and invite for more maybe explanation. I think this is a very timely, very important, and very complex issue. One of the things I remember is that if you go back 10 years ago, when we were talking about big data, we have lots of big Vs. And one of the things I noticed that a lot of the 5 Vs, as we are moving into AI, we're sort of forgetting about the Vs. When we talk about the 5 Vs, I think it means in big data, we have to focus on the data's volume, velocity, variety, veracity, and then value, especially value. And when I saw the radio plot, nobody had mentioned. So that's one comment. Should we actually have some continuity as we move from big data to AI and not forget what we have learned in the past? And the second is, I think if we are considering everything, right? So it's already, I saw the radio plot is already 7. I think that's a maximum what human cognitive load can handle. But then if we add additional things like variety and bias and value, and my mind will explode, right? So I don't know about you, but it seems that there's endless things that we can add in there to call it AI ready. What about the users? So if we think about the users, one of the success of ChatGPT is it doesn't care what kind of a format and everything. You throw a picture of the skin with a suspected like a cancer, and then it actually try to say something. If you actually give more medical imaging and then or wait for the ChatGPT to evolve, it will probably say something better. But when you go to maybe a dermatologist and they will say that this is bad, and then what is good, and then they will show you something good. And then if you look at Microsoft, they're saying what the doctor is saying is bad, and then the better version of AI is good. So it seems to me that there's a situation, depending on the use case scenario situation, the AI readiness seems to be shifting. Have we thought about that, like a situation context? For example, if you're in the drug discovery context, FDA will come in and look at every piece of evidence and say, no, 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 just reject, reject, reject. But if you're not in that context, maybe we should accept, accept, accept. So it seems that this AI ready, the audience is not very well articulated. I wonder if people can comment on these points. Thank you.
I have Thank you very much, Jake. This is absolutely right. You know, this as Barbara was pointing earlier today, policy changes, ethics changes, and all of these things we have to adapt. I absolutely agree. And as a matter of fact, Tim and I have been reflecting with our teams on the fact that from when we started, things have already evolved. We've learned more. We have been working on the process of generating the data sheets. And with this, we've been thinking about how can the grand challenges most effective represent their metadata? And is this exactly the amount of data that we need? And through the process of creating what's valuable, there was a back and forth with the PIs and people who are involved with the actual process of birthing these data sets. And we have realized that it evolves. So I agree with you. This is a situational context, and the definition of AI ready has to evolve with it. But by the same token, at a certain point, we have to put if nothing else, a snapshot of where we are in this context of the readiness of the data sets and generate our, if nothing else, our status of where we are right now. With the context of the grand challenges in the status of data generation in which you are, we can define right now AI readiness looks like this, with the provisions that it might change as well. So I know that we're thinking about this. I know it's not static. We'll try to do a snapshot as static as we can, but absolutely considering that things will evolve. Sandra, did you want to share something?
Yeah, maybe, Jake, great question. Maybe I'll adapt that word context to kind of downstream use cases. That different use cases require different levels of readiness or value that comes from the data set and what they want from it. So I've been thinking a lot through the lens of some of the other work we're doing. As many of you know in this audience, agentic systems are the latest buzzword. And when you give data to an agentic system, you want to understand, are they doing the right thing with it? Or can they even interpret it in the right way? As Yael may have mentioned before, in the context of the boys data set, our hackathons are super interesting because humans play with the data and tell us what they like, don't like about it. And there's a lot of embedded knowledge in that system. And so one of the questions we have is, if you can connect embedded knowledge to AI readiness, where are the impedance mismatches? And I think when we think about AI readiness, I've been at least thinking through that lens of an impedance mismatch of where are we missing pieces of information? Where are we missing aspects that we should have been curating alongside the data? And this is why I said earlier that while on one hand, we're trying to reach that outer circle, we want to re-operationalize some of these things to see, are we actually making this more useful to our downstream consumers, which are going to be both humans and machines?
I can, yeah, I just wanna interject this. So Jeff, always good to hear your questions. I think maybe one simplified way to define success of AI readiness is to say, can you actually develop models that are ready to be deployed, to be used in clinical practice? I think we should really think far in that direction, not only making the data ready to be used by models, but really that model coming out of that process is ready for deployment, right? I think that will probably guide us to simplify those different criteria to just single one goal we want to reach. How many models from this consortium can be, it can be produced from the data we are generating. So that's my perspective.
I will respond to the second question that Jake asked in terms of verifiability. That if there is disagreement between, let's say, a doctor's opinion and
Simon, could you speak a little louder, please?
sure, yeah, sure. Thanks. I'll speak to the kind of like the second part of the question that Jake was asking in terms of I'll bring it to the in terms of verifiability question. So I don't think it's going to be always possible to reproduce what went through the AI, but at least to some extent it can be like if we have a whole chain of evidence that what really happened in each step, we at least know how the decision was made. So if by current AI readiness criteria that we have, if we can get to that point, I think that's also an improvement compared to what we had before.
Yeah, so the way I think about this is a little bit, I put on another hat. I do, and I teach a lot with human-computer interaction and usability in biomedicine. And in those domains, we have, a set of existing heuristics that can help us say whether or not we think an application may be usable, for example. But it's never going to, meeting those heuristics is never going to guarantee usability because really only the user can define that in the setting. So I think it's helpful to think about, frameworks that can help you say, here's where we're starting and we have to have, this is the minimum of what we need in order to get started. But you still have to be evaluating at every stage. Are you really doing the proper things? Is it meeting the requirements, say, for the FDA or for clinical use? And I don't think you can do that up front right away. I think that's just too big of a task to lift.
Okay, Harry, one more question, and then, so we have 5 minutes left. I was just given the flag. Harry, one question. We'll try to go fast, and then we can get to one last question.
All right, I will also be as fast as I can here. Yeah, this is Harry Caulfield from the Lawrence Berkeley Lab and the Bridge Center. And I want to just get briefly back to this idea of AI readiness for tools and the idea that some of the tooling that you'd want is for doing the data validation and running through sets of schemas just as a way of saying, okay, yes, we match this schema. We don't match this other schema. But one of the things that we realized fairly early on was that many of the guidelines that people were working against, even things like the data sheets that have come up a lot, needed to have a fair amount of massaging to get into a computable state to begin with. And then given your individual domain, there may just be kind of sets of community guidelines that have never been formalized. They're just kind of accepted as part of the community that this is what you do with your data. So I guess my question is kind of where do we go next in terms of making more of these guidelines into something that can be computable at all? I mean, not even AI ready, just formalized in a computable way. It's tempting to say LLMs would be up to the tasks, or even just kind of these agentic methods. But what is there any consensus about this?
Well, I think when we think about like specifications and standards and checking them, I think you have to think about it as an evolving process where people come to more consensus over time. And so we sometimes have a standard and it's proposed, and I think people kind of generally understand like, okay, this is the concept of the standard. But then when they start digging in and people start looking at it different ways, they find nuances that hadn't been properly detailed out or tested. And so I think for like in working on like APIs and stuff, we've noticed like, okay, we wrote the specification in open API. Technically that we're done, right? No, it's like now people start implementing servers that speak this thing. Do they respond in the correct order? And so now it became about unit tests that had to be added to the specification to make sure that functionally people were doing the same thing. And those unit tests continue to get more and more tests added to them as more and more of these kind of corner cases become identified by the community. So I think there needs to be a recognition that specifications, they hit their 1.0, everybody agrees on them, and then they still need to kind of be incremented and adapted as people discover what did we actually forget or not, kind of just assume was the same across the board, but was not.
Maybe I'll just, in a different project, we are sharing data sets. And what we are building out there are auto-generated notebooks that allow you to work through the data set. And we're then evaluating how good are these notebooks in the context of knowledge around what we know in that space. And I think that kind of interaction may help shorten the iteration cycles using some of these AI technologies, using knowledge, using schemas, and also tell us where the holes might be a little quicker than some of our current processes. So again, I think this is embracing AI as a tool and a technology, but also kind of seeing that our data sets are AI ready in that same sense.
I probably have a counterexample or an edge case, if I may say. So, for example, if sometimes data sets, like we have found out recently, the data sets are embargoed. In that case, we only have the schema to actually go forward with, right? So we can export the schema and then validate the schema. We can't really examine the data because it is embargoed, and practically so because of the publication requirements and all the research requirements. So I think sometimes like this limitation of not being able to creating a data sheet based on the data set is it's acceptable, especially in this case.
So I want to throw in a quick idea, right? So data and tooling should go, together. Now, large language models can reason. So what if we actually can dynamically, change the tool by using the code generation ability and reasonability of the model? So you reason over a specific data set and then modify the existing code, GitHub, and generate a purposefully built code for handling that data use case. So I think that would be a very cool agent to build. And indeed, I think it's maybe the way to go. Make it super dynamic, super personalized.
My comment, I think, is the analog version of that, which is that, and we heard this in the last panel too, the importance of iteration, whether it's in ethics or standards or AI readiness. And I think the value of this whole effort is the community that we built and the ability to contribute to all these different efforts and making sure that people have the ability to speak up and to, present edge cases that drive new development. Not to say that the technology won't provide an interesting solution as well, but I do think the community effort is important too.
Oh, I want to cheer and say yes. Our second questionnaire person disappeared. So I think with this, Alex will give me the nods. Thank you so much. Please don't let this be the last time we touch this conversation. We have Slack on the entire Bridge2AI. We have emails, lots of meetings that you can join. So please don't let the conversation stop here. Thank you so much for being here.
Okay, hang in there, everyone. One last session before lunch.